Welcome, 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 y'all. We're out here talking about circles and sectors. Let's kind of get into it. We're going to start with circles and parts of circles. So, as it said here, it's about circumference. Now, circumference is the distance around the circle. That's a horrible circle, but a circle nonetheless. Now, unlike, we don't call this perimeter because perimeter is specifically for shapes that have edges. So that circle does not have edges, but it does have a distance around, so we call it circumference. Now that can be found by taking 2 times pi times radius, or 2 pi r, 2 pi radius. All right, that's circumference, distance around. We also get the confused sometimes with area. Let's talk about area. Now area is the stuff inside the circle, so the inside of the circle, all the good stuff inside the circle. Now that's found by taking pi times radius squared. Now you have to square your radius first and then take that times pi. Even though it's kind of written backwards like this, it's just how they standardly write that. And it's because pi is a number. And people ask, like, why is pi before the radius? Well, because as of right now, pi represents a number, irrational number, but a number nonetheless. So if you had x times 3, you eventually write it as 3x. So the idea is the same. We don't know the radius, but we leave the number in front like this. So let's kind of start with something like this. Now, as you go through the homework and you go through the assignments and tell you to round to 2 decimal places or round to the nearest tenth, 1 decimal place, that's fine. But let's wait till the very end. So for example here, we're looking for the circumference. The circumference, again, circumference equals 2 times pi times the radius. So the radius is 6. So we're going to do 2 times pi times 6. We'll multiply whole number with whole number, we get 12 pi. So this is the exact form. This is the circumference of this in exact form, in pi form. Now, as it tells you, round to the nearest tenth, we'll take 12 times pi in our calculator, and we get 37.699, or 37.7 units squared. Okay, so wait to multiply the pi to the very end. It gives you a more accurate answer to what they are looking for. Now let's look at area. Again, area of a circle is, again, pi radius square. Pi radius square. Now, we still use the same radius for the same circle, so we'll do pi times 6 square. Now you have to square your radius first. We're getting 36 pi, and that is our area in pi form, an exact form. Now, as we round this out, we'll do 36 pi. We end up getting 113.097, or 0.1 units square. I put square up here, and that's wrong. I'm sorry. It's just units because it's not two-dimensional. My bad. It's just units. But right here is units square. So let's get to the other part. Let's talk about sectors. Now, a sector is a certain region bound by 2 radii. So this is a radius, this is a radius, together makes radii. Radii is plural for radius. And so it's bound between 2 things. There's a certain number of degrees that's bound in there as well. So we're looking for a slice of the pie, a certain area of the pie. So let's kind of see how that's done. So you set these up like a proportion. Now there's another way in equation form, but we don't mess with that just because sometimes you never know if you're looking for the area, the radius, or the degrees of the circle, excuse me, of the sector. So the way we set this up is we set A represents the area of the sector. So that's our red part right here. Over pi radius squared, which represents the area of the circle. Circle. There you go. Dot messed up right there. That's equal or proportional to the degrees of the sector. So the degrees are bound within here. Over, what do you think 360 represents? Yes, the degrees of the circle. That's how we do it. So part over whole, part of whole, part of the area of the circle over the whole area of the circle, part of the degrees of the circle over the degrees of the entire circle. So area of the sector, area of the circle, degrees of the sector, degrees of the whole circle. So let's try that out. So we have, again, remember, area of the sector over pi r square equals to the degrees of the sector over 360 degrees equals proportional. So on this problem, they're saying, hey, your radius is 6, your degrees is 60. What is the sector area? So we are looking for A. So it'll be A over pi radius square is equal to the degrees of the sector, 60 over 360. So let's kind of simplify this for us ourselves. So again, you can reduce right here. So those is 60 goes into 60 one time, 60 goes into 360 six times. So that's 1 over 6. So those smaller numbers here. So we got A over 36 pi on this side, because 6 squares 36 with pi. We leave it in pi form until the very end. Is proportional to 1 over 6. This is where the magic happens, y'all. Once we have this set up and everything simplifies as much as we can, we are going to cross multiply. So A times 6, it will be equal to 1 times 36 pi. So A times 6 is 6A. That's equal to 36 pi. We'll then go ahead from there and divide both sides by 6. So divided by 6 to get our area isolated. That cancels. We get A equals 6 pi. Now, that could be the final answer if the question is in pi form. So 6 pi units squared, but let's go ahead and multiply that. 6 pi, that gives us 18.849. We're going to go ahead and do one decimal. Actually, we'll do two decimals this one. So it's 18.849. That gives us 18.85 units squared. Be mindful, are they asking for tenths or hundreds? Hundreds, TH. So one decimal, two decimal. We'll say two decimal in this one. So let's look at another way of these sectors. So this other one right here is saying that, hey, this time you have the area and you have some degrees here and all that stuff. You're looking for x, find x. So in this case, x represents the radius. So in our formula here, a over pi r squared equals x over 360. We're looking for this. That means we have to have something for our area and we'll have something for our x over here. Well, let's find those things. So look at the problem over here. It says area is 128. So we got that 128 over pi r squared equals. We need our degrees of the sector. So we're looking for this. It is not 208. Understand this 208, if you use kind of common sense, the half of a circle is 180. Well, if the white represents more than half, that means this 108 represents that. So to find this right here, we're going to just take 360 minus 208. That gives us 152. So that'd be the degrees of the sector. So 152 over 360. Now we can reduce, but I'm not going to do that just because I don't know the biggest possible number. I can reduce it, but let's go ahead. We have a calculator, so let's multiply that. So 128 times 360, 128 times 360, you get 46,080. That's equal to, when you cross multiply right here, 152 pi r squared. All right, so we're trying to get the radius by itself. We're trying to get r by itself ultimately. So we eventually got rid of the 2, and we got to get rid of all this. So this is 152 pi times that. So then to get rid of it, we're going to divide both sides by 152 pi. 152 pi. Now, if you're doing this on the calculator, this is what you have to do. You have to type in your 46080 and then divide it by, whether it's a division symbol like this or a dash. And then when you put in the 152 pi, you have to put parentheses around it. If you do not do that, then you will be given a wrong answer. Now, let's get the right answer first. So we do 46080 divided by parentheses 152 pi, and you get roughly 96.4981549. I'm going to carry a couple numbers for now. Now, if you do not put that right, if you just put it in like this, 46080 divided by 152 pi, what the calculator is saying, because the calculator is only as smart as the person that uses it, it is thinking that you're taking 46080 divided by 152 and then times pi. So it's not only going to not divide pi into that as it's supposed to, it's going to divide just the 152 and then times the pi. So you got to make sure you put parentheses around that. And that gives you, if you did it wrong, 952.398615. So it's very two different numbers, All right, so back to the problem. So we divided that right there. Let me erase this so I can have some room. Okay, now this is what happens to this. So this becomes this. This still equals r squared. Now, what to do here? Well, if we're going to divide r squared, we're going to square root both sides. Now, if you still have the number 96.498154449 in your calculator, all you do is you hit second square root and then hit second answer. No, plug in that answer right now. But if you're not, just carry a couple of numbers and it should round it at the very end correctly. I always use at least 5 numbers, but since I wrote these down, I'm going to put it in just like that. If you do it right, your answer as far as in 2 decimal points should be 9.82 units square. That equals your radius. All right, 9.82. 2 more problems and we'll call it good for this lesson. All right, so here the question is find the area of the shaded region. We have 2, and we're going to start with the top one. We have 2 circles bound within a bigger circle. So we are ultimately looking for the area of this shaded part. So individually, this is a weird, kind of like a curve. Almost looks like a, what would you say? Some sort of like necklace. Pretty cool necklace. The base of an owl, something like that. Now, here's the thing. So ultimately, the goal is to find the area of the big circle. So if we find the area of the whole circle, and then we're going to subtract the area of the smaller circles, the 2 smaller circles, the white circle. So that takes out those spots right there. And then we get the area of just the shaded part region only. Well, let's do that. Let's find the area of the big circles. So if this is 4 and this is the center of the circle, it means this is 4 as well. Making that as 4 because these lines mean they're congruent, and then making this 4. So that means the whole distance across is 16. So the radius of the big circle will be just 8. So that's what we're going to do. We're going to take that as 8. So we're going to do pi 8 squared. Okay. If we do that, we square that, we get 64 pi. So that's the area of the big circle. So I'm going to change the little ones. So let's look at the little ones. So the little ones is just 4. That's the radius. That means the area of that. And since it's all these little segments are 4, that means this is also 4 as well. So we're going to do that information. So the formula for that would be pi r squared. So pi 4 squared. We square that, we get 16 pi. And we have 2 of those, so we can subtract 16 pi twice from the area of the whole thing. So 64 pi minus 16 pi minus 16 pi ultimately gives us 32 pi. Now in pi form, that's our area. We're done right there, units squared. But let's go ahead and round to 2 decimal. That's the nearest 10, so 1 decimal. So we're going to take 32 times pi. We get 100.553 or just 5 units squared. All right. So big circle minus the 2 little circles will give us our answer. So using that same concept and mindset we got right now, we have a square. That's our big shape. And we're looking just for the edges of the square because there's a circle on the inside. So if that's the case, then we're going to be taking big square, area of the big square, minus area of the circle. So this is a square. So a square is side by side, as we learned 2 lessons ago. So it's 10 times 10. We end up getting 100. The circle is pi radius squared. Since the distance across the entire circle is 10, we can go ahead and take the radius as to be 5. So we're going to do pi 5 squared, giving us 25 pi. Now, in exact form, we're done right there. That is the area because they can't subtract us the r. You leave on that. But again, we're round to the nearest 10, so we'll just put that in the calculator. 100 minus 25 pi. You do that, you should get 21.46 or 5 units square. All right, hopefully that helps some of you guys that are either gone or didn't quite get it the first time. Have a great evening, y'all.